guys, here we go. Review day. Tell me what you got. What do you want to do? Tell me where it's at, what number it is, all that kind of stuff. Yes, and P7 homework. P7 homework. 1C. 1C. All right, here we go. So the problem looks like this. All right, so what do you think we're going to do first? Just based on everything else that we've ever done, what do you think we're going to do first? We're going to get a 0. So we're going to get a 0. I'll put things in order while I'm at it. And then I notice that I can take out an X, call that the GCF. And then I notice that the thing I have left, when I take out my GCF factors, so now I'm going to draw a number line, and I'm going to put 3 dots on my number line. Where will those dots be? 0, 1, 4, and 2. So 0, 1, 4, and 2. This is a number line, so they're on there in that order. Okay? Now I'm going to pick a number. Any number that's not those. So, 1. Now 1 is here. If you pick the number 1, what we are trying to figure out is, do I shade here or not? Okay, inequalities, we're going to do some shading. So, I'm going to put 1 in. I'm going to put 1 in here, and here, and here. So what do I have? I have 1 times 3 times -1. So what does that give me? That gives me -3. Is -3 less than 0? Yes. That means that numbers in this area works. I'm going to shade that in. That works. If it hadn't have worked, I wouldn't shade it. Shade it if it works, don't shade it if it doesn't. Okay? Now, I told you the other day that as long as none of your factors are repeated, so in other words, I hope I told you this, I meant to, I'll tell you now. As long as none of your factors are repeated, that would mean I have a repeat factor. As long as you don't have that, we have x cubed, 3 dots, everything's good, then the shading alternates, always. So since that one's shaded, I know that one's not, but this one is. So my answer is everything from -infinity to 0, or everything between 1/4 and 2. Okay, Ann? Okay, good. Yes, Julia.
I have another problem.
Sure.
Can we do number 3 on the review factor?
Review sheet, number 3. The building was purchased 8 years ago for $137,500. This year it was appraised for $102,000. Find a linear equation that represents the value of the building X years after purchase. So I am going to think about this as a couple of ordered pairs. 0 years after purchase, so in other words, at the time of purchase, that was the house value. 8 years later, it was $102,000. So what do I have here? 2 points. My directions say write a line. So what do I need to do to write the equation of a line? I need to find the slope. So 137.5 minus 102,000, always y minus that slope is going to be a negative number. Does that make sense in the context of this problem? Yeah, because why? The value's going down. If you want, you can reduce that fraction, or you can just leave it as negative 4437.5. Does that look okay? Now, because, see that point right there? That's a special point. Because that's a 0, what is this point? That's the y-intercept. So now I have my m, and I have my b was given to me. So my equation is negative 4437.5x plus 1375. There's my linear function. Now I need, what will the building be worth 13 years after it was purchased? So I'll take my equation and plug in 13 for x, and now figure out what that is. Okay, Julie, got it?
Yes.
Okay, guys, when you see the words linear equation, you have got to think about, I need a slope. Because if you're going to write the equation of a line, you're always going to need your slope. Okay? All right, what else we got? Yep. B7, problem number 3. Projectile going straight up. Okay, I will give you the formula if you need it. I'll write it down up here, and then you'll have to figure out what it is for your particular equation. But, here's my projectile motion formula, so let's see. It's launched straight up from ground level with an initial velocity of 272 feet per second. So what's that going to look like in terms of my formula? Negative 16t squared plus 272t plus 0. Initial height is 0, all ground level, we're on the ground. So there's my formula, my equation that I'm going to use for this problem. When will the projectile's height above ground be 960? So remember, this is your height at time t, so this is where 960 is going to go. Right? So I'm going to go ahead and move that over another quadratic. And just for fun, I'm going to see if I can divide everything by negative 16. Does negative 16 go into 272? It does. Does it go into negative 960? It does. Now, you don't have to do that. That doesn't impact your answer at all. But now that I look at it this way, I can see that it factors. Factoring is always going to be your fastest route. Doesn't always work, but it's always going to be fastest. So we're going to have T what?
3.
No, because they both got to be negative.
-5.
So I have to be 5 and 12. So that means T is 5 and T is 12. So when is the ball 960 feet above the ground? At 5 seconds and at 12 seconds. So if you think about it, here's your object being shot up from the ground and it's going to come back down to land at some point. Here is 960. That happens at 5 seconds and at 12 seconds. So the next question says, when will it be more than 960? Well, won't more than 960 be in between? So that would be everything from 5 to 12. And then, when will it be less than or equal to? Well, less than or equal to would be everything from 0 to 5. Or everything from 12 to what? 17. And we know that's 17 because that's a parabola. If that took 5, then this is going to take 5. And then it's balanced. Okay? Alright, what else?
You do 4 on 272?
I can. I do want to remind everybody though that the test has more than P7 on it, so we want to make sure we're doing a comprehensive review. Okay. So P7 says an open top box. My piece of paper is 24 by 32. I'm going to cut corners out. And I want the volume to be 1520. So how do I find the volume of a rectangular solid, a box? Length times width times height. So my volume is going to be my length, which in the beginning my length was 32. But remember, we chopped a chunk off both ends. So now this is my length. So it's 32 minus 2x. And then my width is 24 minus 2x. And my height, remember you're folding up these flats, the height is x. And that's the volume. And I want the volume to be 1520. Okay? Now, please understand, this is not going to be a quadratic equation, right? This is going to be a messy, messy cubic. So we're going to do this on our calculator. There's no chance of me factoring this. So I'm going to do it on my calculator. So what do? Before I start, I am going to figure out what my window is going to need to be. Because my domain in this problem is critical, and this is your domain right here. Think about what x is, right there. What's the smallest it can be? 0. What's the biggest it can be?
12.
That's 24. So could I take 11 off each side? Yep, could I take 11 and a half off each side? Yeah, very weird looking box. I can take everything off up to 12. So x min is 0, x max is 12. It's my smallest dimension. That's the one I got to look at. All right, now what about y's? Well, remember, in the beginning, this was your y, right here. So y is the volume. What's the smallest a volume can be? 0. And in this case, since I'm going to be graphing this, and I have to go at least this high, I'm going to pick a number bigger than 1520. So maybe 1700. I don't know, pick whatever you want. Bigger than 1520. Okay? So then, that's how my window is set. Okay? A little frustrating when we come in and we say, Miss Ford, I can't see a picture. Set your window up, and then you'll see the picture. So, all right, so I'm going to put in my equation. So this is going to be one equation. Don't FOIL it out. If you're putting it into your calculator doesn't care. So leave the parentheses. Don't waste time. Put this in as your second equation and hit graph. Now, it's not a parabola because this is a piece of a cube here, but you see a hill and a line running across it. So your job is to figure out where it crosses. At those 2 points is where the volume is 1520. So, second calc intersect, left bound or first curve on the left side of the point, second curve on the right side of the point, yes, somewhere in the middle. I got, this point is 3.793. And then I do it again. Second calc intersect. Set my cursor to the left of the second point. So now I'm setting it over here somewhere to the left of the second point. And then to the right of the second point. So over here somewhere. And then in between, I got 5.298 for that one. Question number 1. Where, or what size should the corners be to get a volume of 1520? 3.793 inches or 5.298 inches? How about if we want the volume to be no more than 1520? Well, no more than 1520 would be this, right? And this. So what's that going to look like? Look at your x's. Everything from 0 to 3.793. Wait, it says, where am I? No more than. So no more than is less than or equal to. So I got to put bracket there. Or 5.298 to what? Not 0. Those are x's, guys. What's my biggest x? My biggest x is 12. We already talked about that. X can't be more than 12. So we're going to end it at 12. Okay? What if I want the volume to be less than 1520? Well, isn't that the same question? Except now I'm not going to include those. So no more than and less than are the same, except no more than includes the endpoints and less than doesn't. All right? Okay, what else? Preferably not in P7. We have to do some other stuff. Yes, ma'am.
On P6, can you do 1D?
P6, that's 7. P6. 1D. So I am dividing 2 times my first number. So 2 times my first number is -8 plus 2i. And I am dividing that by my second number. How do I do that? Multiply by the conjugate, top and bottom. And then I start boiling. So -48 plus 24i plus 12i minus 6i squared. 36 minus 18i plus 18i minus 9i squared. Okay? Let me just start simplifying. This is going to make a 36. And what's going to happen here? This is going to become
Plus 6.
plus 6. So that's going to be -42. And then on the bottom, I'm going to have 36 plus 9, which is 45. Now I want you to look carefully at these 3 numbers. Can I reduce that? By 3's. So that's going to be -14 plus 12i over 15. And then I'm done. right, what else? Anything else? Yes, Oscar.
You, on the review, 8D.
8D on the review, yep. These people say that's real quick. There's another Julia. This is not here. Olivia. Addie. All right, so what did you say, Oscar? I forgot
I
already.
said 8D
8D?
on the review. Yes, ma'am.
8D on the review. Here we go. 8D on the review. Okay, this is another one out of P7. That's okay. All right. I know we'll do it. So what do you think my strategy is going to be? Yep, so x cubed minus x is greater than 0. Okay? Then what do I need to do? Probably factor it. And when we say factor it, we're first of all going to take out our GCF. And then we're going to notice that after we take out the GCF, what we have left is the difference of squares, which is going to factor into x plus 1, x minus 1. Right? So now I'll go to my number line and where will my dots be? There's going to be 3 of them. However many x's you have, that's how many dots you have. So what have we got? I should say, that's how many dots you're supposed to have. It's when that doesn't match that you run into issues. Okay? But we match. We're going to have 3 dots, and what are they going to be? -1, 0, and 1. So pick a number. I can't pick a number that's a dot. 2, so I'll pick 2. So if I put 2 in for all of the x's, I'm going to get 2 times 3 times 1, which is 6. Is 6 greater than 0? Yep. So this is going to get shaded. Since I shaded that, I won't, I will, and I won't. So what's my answer? -1 to 0, or 1 to infinity. Okay, what else? Let's go, guys. Let's go. Julia,
Number 7 on the
review sheet number 7. Find the coordinates of Q. Okay, so I've got PQ, so here's P, here's Q. And I know that P is -8,4. And I know, I don't know Q, but I know the midpoint, we'll call it M, is 1/5 -7. And I need to figure out this. Right? So a couple ways you can do this. How do you find midpoint? Just in general, what's midpoint? Midpoint is the average. So if I take my x and my x, add them together and divide by 2, I should get 1/5. Would you agree with me? And if I add 4 and the y and divide by 2, I should get -7. That's what it needs to be. So cross multiplying, -40 plus 5x equals 2. So 5x equals 42, and it looks like x is 42/5. So this point, this guy right here is 42/5. Here, 4 plus y equals -14. So it looks like my y is -18. And that's it. Those are the coordinates at that point. Okay? All right. Kyle, did you have a question? Did you say something to me?
I was gonna say number P on P2.
On P2?
Yeah.
I have published all the answers, by the way, guys, so it's all opened up now and you can see them. But number 8 on P2 says solve using distance. So this is an absolute value problem. And we're recognizing that absolute value is very tightly related to distance. Because if I said to you, what is the distance between 4 and 11 on the number line, you would subtract them, right? But knowing that it has to be positive, we'll take the absolute value. So the absolute value of 4 minus 11 or the absolute value of 11 minus 4 is the distance between those two numbers. So that's the idea we're doing here. Now the problem is, I can't have this 2 here, or 1/2 here. That can't be there. So I'm gonna times everything by 2 to start with. Everything by 2. All right, so 2 times this, 2 times that, 2 times that. The second issue is that distance is a difference, not a sum. It's a difference. So I have to think about this as the difference or the distance between something and negative 20. So here's negative 20 on my number line. And I know the distance forward and backward, the distance is 2/3. Actually, it's more than 2/3. So it's going to be past that and past that, because it's more than 2/3. This is exactly 2/3. So what are those numbers to be exactly 2/3 away? I'm going to take this number and subtract 2/3. So I could say negative 20 and 2/3 if I wanted to. That's a mixed number. That's what that number is. And then I'm going to go this way 2/3. So that would be negative 19 1/3. Since I want to be, I don't want to be more than, I want to be less than. You guys almost let me get away with that. That's a less than. So I want to be in here, don't I? If I'm less than 2/3 away, that's a less than right there. So my answer is everything between those. So negative 20 and 2/3 to negative 19 1/3. I want my distance, Kyle, to be less than 2/3. Here's where it is exactly 2/3. So less than would be closer to 20. All right, what else? What else? Julia,
11C
on the review? 11C is an exponent simplification problem. So, remember, we got answers to this, folks. Answers are posted. So I'm not even gonna write the second one. I mean, I'm eventually, but I'm gonna go ahead and simplify this one first. Now, my particular style of simplification might be different than yours. But when I look at this, I immediately want to clean up what's on the inside. So I don't worry about anything out here. I want to fix this. So my 3 and my 4, nothing can happen to. My A's will cancel and leave me with an A on the bottom. My B's will cancel and leave me with 2 of them on the top. And my C is just there. Now I notice that that's a negative exponent on a fraction. So that's going to turn the fraction over. And then the exponent becomes positive. Now this is the way I do the problem. You don't have to do it in this order, but you better get what I get, which is 16a squared over 9b to the 4th c squared. That's what I get for my first fraction. Okay? Now I'm going to repeat for the second one. So I've got 6. And I'm going to do exactly the same thing. I'm going to focus all of my attention on inside the parentheses. So I've got my 5 and my 6, can't do anything with that. Now, what about my A's? Well, where are these going? To the top. So there's 2 up there, I'm bringing up 4 more, so I'm going to have 6 A's on the top. Where are these going? Down. So I already have 1 B down there, I'm bringing down 3 more, so now I'm gonna have B to the 4th down there. And that's all just squared, so there's no flipping going on. So that fraction is 25A12 over 36 B8. Now I gotta put them together. So, let's see. I've got a lot of numbers. I've got a 16, 25, 9, and 36. So I think I'm gonna try to reduce that a little bit. I can take a 4 out of 16 and a 4 out of 36. Does that seem reasonable? And I think that's all I can do with the numbers. So I'm gonna have on the top, I'm gonna have 100, and on the bottom, I'm gonna have 81.
So if the 36 would happen to be on the top, could you still take a 4 out of the 16 and 36?
No, they have to cancel. They have to be on top of each other.
Okay.
Okay, we're multiplying them, so,
Yeah.
so yeah, it's like reducing the fraction of 16 over 36. 16 times 36 doesn't reduce.
Yeah.
Okay, now what about my A's? Looks like on the top, I have A to the 14th. On the bottom, I have B to the 12th and C squared. There we go. Okay, so one step at a time, easy. All right, who else has a question? Yep,
12 on the review package.
I had no idea who your dad was till last night.
I only about meeting you last night,
Yep.
or seeing you last night.
Yep, oh, we've met many times.
Yeah.
All right, so number 12, so we're solved by graphing. So y equals log 2x plus 7, and y equals 5x minus 3. Now, my window is all messed up from the last problem I did, so the first thing I'm gonna do is zoom 6. And now I have just a regular piece of graph paper in front of me. That's what zoom 6 does. It's like me handing you a piece of graph paper. All right, so I'm gonna put in my equations. Turn out the old, put in the new. Log, you have a log button. 2x plus 7 and 5x minus 3, the graph. And I get something that looks like this. That's what you should get. This is a logarithmic curve. That's the shape of a logarithm. And then this is your line. And I want to know where they're equal. Solving this system. So where they're equal is right there. So second calc, intersect, left bound is good, right bound. Looks like they intersect at the point .787, comma, .933. And both of those are the answer this time because this is a system of equations, x and y. Think back to the box problem. The box problem was 1520 equals x, blah, 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 only x's. So the answer to the box problem was the x coordinates. This is gonna be both. Okay? I can give you anything. As long as you have a calculator, you can solve it, right? Just put it in and graph it. All right, what else? Julia? Thank God you're here, Julia, because I don't think anybody else reviewed. Either that or they know everything. What?
For number 4 on the review packet, like, since part A says below the ground, level height above the ground be at least 50 feet, you just said 50 plus 7 equals the equation. Like the same as it was.
Okay, let's let's look at it. First of all, we need our projectile motion formula. So this one's gonna be, well, yeah, I'll just use one. It's gonna be negative 16t squared. What's my initial velocity? 100 t. What's my initial height? 24. So this is my setup. Okay?
Which question is that?
This is 4. So I'm getting ready to do part A. So here's what I want you to think about, Julia. This thing has started at 24 here. We've thrown it up into the air, it's gonna come back down and hit the ground. Somewhere up here is 50. I wanna know when the height above the ground will be at least 50. So aren't I looking for this chunk of my picture right here? So the first thing I need to do is find these 2 points. That's where it's exactly 50. So these numbers do not look pleasant to me, so I'm gonna go ahead and do it on my calculator. So I'm gonna y equals, clear out all the old. I'm gonna put in negative 16x squared plus 100x plus 24. And then I'm gonna put in 50. And I'm gonna go back to my window and make some adjustments here. Because negative 10 to 10 makes no sense in this problem. What does X stand for? Time. 0 is your minimum. Now, you can leave 10 as your maximum, we'll just see what happens. How about for Y? What's my minimum height? 0. And my maximum is going to have to be bigger than 50, so maybe I'll go with 70. I don't know. Get graph. Now, you don't see this exactly because you can't see the top of it. But do you see a line coming across and hitting in 2 places? Those are the points you want. So, second, calc, intersect. Remember, if you can't see your cursor, watch the numbers at the bottom of the screen and you'll know exactly where it is. You might have to keep pressing a few times, but eventually it will come in. And this point is 0.272. Second, calc, intersect. And the other one is 5.978. So when will the height above the ground be at least 50? Everything in between 0.272 and 5.978. Does that make sense to you, Julia? Okay, so that's when we're at least 50. When will the object hit the ground? So now we're looking for that point right there. Okay, so basically, don't you want to, instead of setting this equal to 50, don't you want to set that equal to 0? So now I'm going to go ahead and take out my second equation. I don't need that 50 anymore, so I'll take that out. Won't hurt to leave it in, but I'll get it out. And I'm just going to graph that. Now, the problem is my y min was set at 0, so I'm going to go ahead and change my y min to be like negative 20, just so I can see that point. Otherwise, it's going to be right at the very bottom of my screen. So, graph it. Okay, so second calc 0, left bound, right bound. Remember, you might not see your cursor, you might have to pay attention to your numbers and figure it out. I got 6.481. So when does the ball hit the ground? After 6.481 seconds. Oh, and that's it. Okay.
So the y value doesn't matter in the math?
What, I want you to read both questions. both questions ask for a wind. What is a wind? A t-value, an x value. Yep, that's the answer. Now, if later on we'll do a problem where we want to find the maximum height of the ball, that would be right here. And if we want the maximum height, we'll be looking for the y value, because height's the y, right? But we're not here, we're doing wind here, so that's x. Okay, what else? Come on, guys, I know it's hotter than heck. I know it's Friday. I know if you're a football player, you're just dying to get out of here, because you don't, I think you get to leave, right? Hey, don't even get me started. Yes,
13 on the review.
which one?
13.
13 on the review. Solve algebraically, show all work. Okay, so what do we do here, guys? What do we do? Solve algebraically, show all work. What do we need to do? Gotta pick a variable to eliminate. Doesn't matter which one do you think you want to eliminate? Makes no difference whatsoever. Which one? Y. So if we're gonna eliminate y, I think I'm gonna start with these two equations, because if I choose to eliminate y, won't they eliminate? So that's gonna be 7x plus 6z equals 15. Now, what if I took my top equation and multiplied my bottom one by 2? That would also eliminate my y's, right? So now I'm doing my top and my bottom, and I'm going to get 9x plus 11z equal to 12. Okay, this isn't very pleasant, but it's doable. So now I pick a variable to eliminate. Yeah.
That top y is supposed to be negative.
This guy?
Yes.
Okay, so I copied the problem wrong. Okay. Okay, so that's gonna change things. Thank you for pointing that out. So now I'm gonna have to multiply this one by negative 2. Yep, one of those days. So negative 2, negative 2, negative 2, negative 2. Okay, so now I've got negative 7x and negative 9z. Wait, negative 7x? Oh, I'm looking at the wrong equation. Yeah, negative 7x, negative 9z equals negative 12, is that right? Well, that's not too good to be true. Because now I have negative 3z equal to 3, which means z is negative 1. So then 7x minus 18 equals 15. No, that's not good. Z is negative 1 minus 6. That's better. So 7x equals 21 and x equals 3. So 3 minus 2y minus 1 equals 0. So 2 minus 2y equals 0. So negative 2y equals negative 2. Does y equal 1? So my answer is 3, 1, negative 1. Penny, did you follow all that? Perfect. All right, let's go. What else? Yep. 2 on the review. An airplane climbs to take off with a slope of 2.7 high off the ground. Will the airplane be after it flies 250,000 feet in the horizontal direction? Well, there are a couple ways you can do this, but one thing I want you to think about is, here's the airplane taking off from the airport, and here he is flying, right? Would you agree with that? So the slope of his flight will be rise over run, and he is going up to, for for every 7 he goes horizontally. Would you agree with that? The slope is 2/7. Since this point is the origin, that's the airport, that's where he starts on the ground at time 0, wouldn't this equation just be y equals 2/7x? If we need a linear function, which it doesn't say that, but we could come up with that. And then it says, after he flies 250,000 in the horizontal direction, which of these coordinates, x or y, is the horizontal? X. So don't we just have to take 2/7 times 250,000? It's a proportion, basically. You can say 2/7 equals y over 250,000. So whatever that is the answer to the question. Feet, put feet on it. And that would be the answer. Okay? Come on, a couple more. We can do it. We can do it. Anything. Let's go.
We do 11D.
11. First of all, when you see the square root of a negative, the very first thing you need to do is take out the I. So that's going to be I root 3 times I root 6 times 2I. I'm not going to write the square root of 4 because the square root of 4 is 2, right? Now I'm going to multiply all this together. So I have a square root of 3 times a square root of 6 times a 2. So that's going to be 2 square root of 18. And then I have an I times an I times an I. So that is I cubed. Now what about the square root of 18? 2 root 2. It's 9 times 2. So it's 3 root 2. So 2 times 3 root 2. What about I cubed? Negative I, because it's I squared times I. So it's negative I. So now I've got negative 6 root 2 I. So I usually put my I in between so there's no confusion. But I have a negative 6, a square root of 2, and an I, all multiplied together. There's one more, and I will shut up. Give me one more. Which one? Jacob?
That was D, right?
Huh?
That was D, right?
That was 11D.
Wait, how did you get I put in the 3 and 6?
Sweetheart, how do we handle the square root of a negative?
Oh, there's negative. I was looking, sorry.
Square root of negative is always you start by pulling out the I. Always. That's step 1. It happens to the best of us. I think his mind is elsewhere.
Just do 8D.
8D. 8D. Now, there's no direction, Luke, on how you have to do this problem, okay? I am gonna do it the calculus way, but it doesn't say you have to do it this way. You just have to come up with the right answer. So I'm gonna divide everything by 4. Everything across the whole problem by 4. And then I'm going to recognize that this is the distance between some number and 3/4. And that distance can be either direction from my 3/4, and it has to be 5/4. So what are these 2 points that are exactly 5/4 away from 3/4? Well, this would be 8/4, which is 2, and this would be negative 2/4, which is negative 1/2. Those numbers are exactly 5/4 away. I want to be even more than 5/4 away. So that means I'm going to be further away from 3/4. So negative infinity to negative a half, or 2 to infinity. So you're going to do that problem however you want to, but you got to come up with that answer. Okay? All right, I promised you that was it, so I'll keep my promise. Who's signing up for Math League today? Let's get that out of the way. Anybody bring your $4? You left it in your